Bismillah ar-Rahman ar-Rahim. Peace and blessings upon you all. Dear students, in the last lecture, we saw the NOR implementation of SR Latch, and today in this video we talk about the NAND implementation of SR NAND, NAND implementation of your SR Latch. Okay. Now in SR Latch, what we do is we have it is a sequential circuit. Why? Because we have a feedback loop. In the last video we saw the first time in our circuits design the feedback loop. We had designed adders, the multiplexers, encoders, decoders. They were all combinational circuit because there was no such thing as a feedback loop. Now here we have a feedback loop, right? So in the SR latch, if we want to implement it using the NAND, okay, the SR latch. Now how we're gonna do it? So first let's see the behavior of NAND. Okay, so I will put it here, the behavior of NAND. So this is say A, this is my B. So what can A values have? 0, 0, 0, 1, 1, 0, and 1, 1. And what is NAND? NAND is A and B complement, right? Now what is NAND doing? The NAND is the complement of AND. What does that mean? That means if we have the AND, that AND says if one of the inputs is 0, output is gonna be 0. If both inputs are 1, in that case only the output is gonna be 1. But if it is the inverse of that, that means we're gonna have here the 0 and rest of the guys will be 1. So in the NAND, if we said like in our NOR, using the NOR, if that's the inverse of OR, and here it's a NAND, which is the inverse of your AND says if one of the inputs is 0, output is going to be 0, but NAND will make it as 1. So in the previous NOR implementation, we're talking about the other things, right? Like we were talking about when the input is 1. But here we are having the dialog, which we remember here is if one of the inputs is 0, output is gonna be 1. Okay, this thing we remember. And if both of the inputs are 1, output is gonna be 0. So we remember this thing and we use this thing that if one of the inputs is 0, I will if someone tell me that hey, what will be the output of the NAND gate if one of the inputs is 0? So I don't care what's the other input. Is other input 0 or is other input 1? I don't know. If one of the inputs is 0, output is gonna be 1. And in this case also, one of the inputs is 0, output is gonna be 1. So this thing I will keep it in mind, and I will draw the basic latch of NAND. So how will the basic latch of NAND? This is gonna be the NAND. We've got a couple of NAND gates, and say these are its inputs. Okay, this is my R input, and this is gone my S input, the set and reset inputs, set and reset inputs. Okay, and I got a latch here. Okay, so this is my output going on, this is my output, and then this output is tied towards this input. It's a feedback loop, and this output is also tied towards the input of this. Now the output of this comes back to the input of this NAND gate, and output of this comes back here to this NAND gate. This is our basic latch, okay? Because we've got a feedback loop, the loop which is coming back to you, okay, here, and this is coming back here. So we don't have, that's why it's a sequential circuit. Why? Because the outputs are not just the function of input, but also they are the previous output, also the function of the previous output. What the previous output was, because that becomes the current input, and that has its role in to generate the output, the current output, right? यानी कि जो भी पुराना आउटपुट था वो यहाँ से आके इनपुट आ रहा है ना, तो ये इनपुट मिलके हमारा आउटपुट बनाएगा. तो ये बात हमें सीखने की है कि ये सीक्वेंशियल सर्किट है, क्योंकि फीडबैक लूप है, वापस आ रहे हैं आउटपुट, वापस आ रहे हैं इनपुट को, क्योंकि मैंने कहा था आपको जो कॉम्बिनेशन सर्किट्स हैं उसमें इनपुट्स आते हैं, वो आउटपुट्स में जाते हैं, आउटपुट नेवर कम बैक टू द इनपुट, बट हियर दे कम। और ये नैंड गेट है, तो नैंड का हमारे पास डायलॉग क्या है, व्हाट इज द बिहेवियर ऑफ नैंड, इफ वन ऑफ द इनपुट्स इज जीरो, आउटपुट इज गोना बी 1. Now let us try to think what will be the characteristic table of this basic SR latch. And now we are implementing it using the NAND. Okay, and I told you if this is a latch and I want to make a flip-flop out of it, only thing is if I have a latch, let me write it here, say for example here, if we have a latch and we put up a clock with it, it becomes a flip-flop, which we'll take in our next topics, flip-flop. Okay, right now I just leave it. I am going for the NAND implementation of SR latch. We are done with it. We move on to the flip-flop. Okay, now previous video, which was the NOR implementation, and this one is the NAND implementation. And what is the dialog of the NAND? If one of the inputs is 0, output gonna be 1. Keep that thing in mind. चले, तो पहला हमारा है, अगर ये हमारा R input है, ये हमारा S है, this is gonna be Q and this is gonna be Q complement and this is gonna be state. What is the state of this gate and all? Okay, ये हमारा हो गया ऐसा. So let us make a move. Let me put up a new pen and use a different pen to show this. Okay, I will say first if R is 0 and S is 1. If R is 0 and S is 1. So what is going to be Q and what is going to be Q complement, okay? And what is going to be the state? Because we know if it is Q and this is, if it is Q, this is going to be Q complement. They have to be complement of each other. Now let's think about it. If R is 0, so I'm putting up R as 0 and S as 1. So we will work on what? On the principle that if one of the inputs is 0, output is going to be 1. So if one of the inputs is 0, because I don't have to think about what is the other input. Because if one of the inputs is 0, I don't care what the other input is, because immaterial, other input can, what can be other input? Other input can be either 0 or 1. Chahe 0 ho, chahe 1 ho. I don't care what it is, because if one of the inputs is 0, output is gonna be all the time 1. Right? So output is gonna be 1. Now this is the input 1. When one of the inputs is 1, I'm not sure what the output is. It depends upon the other input. Look, if one of the inputs is 1 but other output is 0, then it is going to be 1. But if one of the inputs is 1, other input is also 1, it's going to be 0. So now if it is 1, one of the inputs is 1, now other input will decide whether it is 0 or 1. If other input is 0, then it is 1. If other input is 1, then it is 0. So if one of the inputs is 1, I have to see what this other input is. Otherwise I cannot generate my output. I'm not sure about that. Now other input is coming 1 from this side. So 1 and 1. So what is 1 and 1? 0. Output will be 0. So that means in this scenario, when R is 0, S is 1, Q will be 1 and Q complement will be 0. Okay, so that means when the Q is 1, so this is a set state. So understood, this is a set state. Okay. In the NOR implementation, we had a 0, 0 as a memory state, because we want, this is a latch, that means it's going to store the data. That means if I remove the inputs, output is going to stay like that as a set. But in my SR latch using the NOR, we had 0, 0 as the memory state. But here, there is a difference. The 1, 1 is a memory state here. Because if I see here the 1, 1, let me put up it in a memory state in the bright red. This is 1, 1. Okay. Now let us see if it is both 1, 1 now. Now I'm putting a 1 here, I'm putting a 1 here. Both are 1, 1. Okay. So what is my dialog? My dialog is if one of the inputs is 0, output is going to be 1. So where is 0? I'm seeing the 0 is coming from this side. Okay. This 0, the previous state was, because previous state was 1, 0. If we had 0, 1, we got the set state. That means 1, 0. That means this is previous output of this is 0. When I am making both current input, I am making 1, 1. but I am seeing the previous output is 1 0, so that means this 0 will come up into it. So when one of the inputs is 0, immaterial what it is, output is going to be 1, so it stays as 1. And 1 1 will become 0, so it stays as 0. That means it stays at whatever the previous state was. If it was 1 0, it's going to stay as 1 0. So that means it is retaining the previous value. So definitely this is going to be the memory state. Okay, this is going to be the memory state for sure. Now we change it. We change the input from, we had the like 0 1, now let's make it 1 0. Okay, now let's make it, this is as R is 1. Okay, it's 1, but S is 0. Now let us see. Technically, if R is 1, it should reset. When the S was 1, it got the set. Okay, and if R is 1 here, it should reset. That means Q should become 0 and Q complement should become 1. Let us see that. So I am saying I have the 1 and S as 0 or reset value as 1. So I know if one of the inputs is 0 here, so it is 0. So 100% guaranteed output of this gate will be here as 1. It will stay as 1 like this. Okay. And what about this? Because its input is 1, so I'm not sure. I have to see the other input also. If one of the input is 1, I have to see other input, then I can tell you what is the output. But in case of 0, I know guaranteed if one of the inputs is 0, output is going to be 1. But if one of the inputs is 1, I have to check the other input. Other input is 1. So 1 coming from this side and 1, 1 and 1, that is 0. It becomes like this, 0. So it becomes 0 1. It becomes 0 1. When the Q is 0 and Q complement is 1, this is going to be the reset. This is going to be the reset state. Okay. Now if I put the memory state on this, let me put the memory in with my bright red color. This is the 1 and 1, the memory. Let us see if it remembers. If I'm making it 1 1 now. If I'm making it 1 1. So let us see if it remembers this or not. So where from I should start? I should start from the 0 again, because I know with the 0 I'm sure that if one of the inputs is 0, output is going to be the 1. So 0 is here. Okay. So this 0 input is coming from this way into this gate, into the, say this is A gate and this is B gate. It is coming to the B gate. If one of the inputs is 0, immaterial what this is, okay, is it 0 or 1, I don't care, because another input is 0, output is going to be 1. So it stays as 1. Now for this guy, 1 is coming from here, 1 is coming here, 1 1 is 0. So output stays as 0. So that means whatever the previous state was, 0 1, it will stay with that. So in this scenario, when it was 1 1, because previous state was set state, so it stays as a set state, 1 0. In this case, the previous state was 0 1, that is the reset state. So it will stay as a reset state. So that means this is what state? This is a memory. Okay. Now the last thing here, the race condition, which was in the NOR gate, 1 1 was the race condition and 0 0 was the memory. And here it is inverse. Here 1 1 is the memory state and 0 0 is your race condition. So if I put up here a 0 0, that's going to land us into the problem. If I put up here the 0 0, say for instance this is my 0 and 0, okay, this can put us in a problem. So why? Because we know if one of the inputs is 0, output is going to be 1. So that means if I am putting it as 0 0, let me rub it a bit. Okay. Okay. So what I am saying is if I am putting both 0 0, and I know if one of the inputs is 0, output is going to be 1. For this case also, if one of the inputs is 0, whatever is out, second input coming, I don't care because it is always sitting with 1. So that means they both will be 1 1. So it is breaking the condition of Q and Q complement. Again, one of the inputs should be Q, other should be complement of it. That is breaking it because both are same. They are not complement of each other. So that's the wrong thing. First thing is that. Okay, so it's breaking the scenario. So what should we say? We say this is not allowed. This state is not allowed. This is the prohibited state because it's giving me not Q and Q complement. They are giving me same things. So this is breaking our Q and Q complement logic. So I should definitely not use it. And इसके बाद अगर मैं memory state में लगाता हूँ, if I put the memory state like 1 1 on it, okay, on the not allowed state, if I put a 1 1 on this state of memory state, it gives me the different problem. The problem is it can set or it can reset. The circuit can set or reset depending upon which gate is faster. So again, there is an ambiguity. I can't say exactly which gate is, whether it will set or reset after this 0 0 state. How? Because if it is 0 0, now I am making it 1 1. Now I am making it 1 and 1. Okay, now you 1 1. So if I am making it 1 1, let me rub it properly because it's not visible properly. Okay, now it will be visible. If I make it 1 1, I'm making it 1 1. Now previous state was here 1 1 also, so they will come up. So if this gate comes, if B gate is faster than A gate, for example, then this 1 will come up as input to this guy, so this becomes 1 1. Okay, if they become 1 1, okay, this gate becomes 1 1, 1 1 is 0, so this will become as 0 then, and this 0 will come up from this side, 0 1 becomes 1, so that means this becomes 0 1, that is a reset state. So it could be reset. Okay, so I can have a reset state here. But if this gate was faster, not the B gate, A gates were faster, so this 1 will come up from here quickly and 1 1 becomes 0. So this will become now 0. Okay, this will become now 0, and 0 and 1 will become 1. So it will become 1 0. 1 0 means set state. So it will set or reset. Okay, it can become 0 1 also, and it can become 1 0 also. And depending upon what? Depending upon which gate is faster. It depends on which gate is faster. If A gate is faster, okay, it will set. If B gate is faster, it will reset. So we are not going to allow that. So that means this is not going to work for us. This is not allowed because this is ambiguous. This firstly breaks the Q and Q complement concept. Then when the memory state comes in, it can reset or set. So will you give a circuit to the people and tell him, I don't know. They will say, what will the output? You say, I don't know. It could be set, it could be reset, depending on your luck, maybe flip a coin. So we're not going to work like that, right? So that's why this is not allowed. And definitely we had to do something so that we remove this state at all. We remove this state totally from our circuit. So that is, we had to do something, okay? We had to do something so that this becomes a reliable circuit, and we do not have this kind of situation which is called the race condition, the last condition, which is a race condition. We don't want to have that, and we want to put clock to it, because without clocks nothing works in computer science. Everything works with a clock. Every circuit has a coming back to it, okay, even though it looks same. This is my Q and Q complement, and this is going to be your two inputs. Now this is my basic latch all the time, okay? And then what I do is, maybe I put up here the NAND gates, and I'm telling you why I put the NAND gates here. But right now I'm telling you that I'm giving this NAND gate some kind of a clock, so that this works on a clock. When the clock is 1, only this gate will work, or when the clock is 0. Maybe this is AND. Let's leave it for the NAND. Let's put it the AND this way. Now this box, okay, is my SR latch, This is the latch, same latch. There's no difference between this and our latch. This is the same latch in a box. And outside I am saying, so this is my latch. And outside I am putting up some clock and some NAND gates. Maybe later we put up only single input with the inverter. And we'll see what's the D flop on JK flip flop. But right now what I'm accomplishing here is a clock. A clock given to the AND gate, because AND is when the both are 1, then the output comes in. So that when the clock is 0, these AND gates will be disabled. So that means as if there will be no input to this latch. Okay. So this clock becomes important because this will enable the working of the latch, because if the clock is 0, these gates are shut off because AND gates will output 0. When this is 1, now whatever, if it is 0, output comes 0. If it is 1, output will come 1. So that means input will go to output only when the clock is 1. Now this was your latch, this piece was your latch, and you have put up your clock with it. Now the same thing will become as a flip flop. Why we call them flip flop? Because they can become 1 or 0. That's why they're called flip flops. And we will discuss about these things in our next lecture. Here I just give a little recap of it. That if we have a NAND gate, and I'm seeing the NAND here, the table, the excitation table or the truth table of it, and I'm seeing one thing, that if one of the inputs is 0, wherever I'm seeing the 0 input, okay, output all the time 1. So that's my dialog. I will work with that. If one of the inputs is 0, output is going to be 1. And I'm seeing if both are 1, 1, output is going to be 0. Okay. Now, I work with it. This is my R input, this is my S input, it's a feedback loop. We know the latch, basic latch, and now I'm putting the inputs. If the input is 0, 1. If R is 0, S is 1. So when R is 0, S is 1, output is going to be set. So remember, when S is 1, it's going to set. If S is 0, R is 1, it is going to reset. And 1, 1 is the memory state, and 0, 0 is not allowed state. So how we do that? Because if R is 0, S is 1, so I start with the 0 because I'm looking at the zeros here, because one of the input 0, output is going to be 1. So 0, output is going to be 1. 1, 1, 0. So it's going to be the set state. Now if this is 1 and this is 0, S is 0. So if one of the input is 0, output is going to be 1. And 1, 1 is 0. So it will reset. Same way, if I have but the 1, 1 state, and the 1, 1 state remembers the previous. That is where the latch comes in. So if it's a 1, 1 state, as you see here, it remembers what was the previous output. If it was set, it remains set. If it was reset, it remains reset. And if it is a 0, 0 state, so in that scenario, because one of the input is 0, output 1, one of the input is 0, output 1, then both are 0, 0, output both will be 1, 1. So when there is both 1, 1, that is Q and Q complement का concept खत्म, मामला खलास. और उसके बाद जब आप memory state लगाओगे, it can set or reset depending upon कि किस गेट ने पहले काम किया. अगर इस गेट ने काम किया तो set हो जाएगा, अगर उस गेट ने काम किया तो reset हो जाएगा, ठीक है ना? That means it's not a reliable state. So what we do next? What should we do next? First, we cannot work without a clock. क्योंकि कभी भी input आके इसको output देगा. So we should have some kind of a control on it. So all circuits, you have even multiplexers or demultiplexers or combinational circuits we have read about, they all have a enable line, which is the clock line, which makes them enable or disable. Are they working or are they not working? Does it make sense what I'm saying? So clock is all the time there. So we have to adapt to this basic SR latch, the clock. So I'm putting up the clock here using the simple NAND circuit. I'm putting up two NANDs because NAND, when there's a NAND gate, for example, say I'm saying, hey, this is my NAND gate. Sorry, AND gate. I'm not using this time NAND. I'm using the AND gate. So if I'm saying it's the AND gate and it has two inputs, okay, one of the input is clock, that will decide whether the output goes or not. Because if clock is 0, for example, 0, I know एंड गेट तो जीरो ही देने वाला है, ठीक है ना. दैट मीन्स अगर ये कुछ भी हो, ये 1 हो या 0 हो इनपुट, ये 0 हो या 1 हो इनपुट, इमटेरियल. अगर ये बंदा क्लॉक 0 है तो आउटपुट 0. दैट मीन्स दिस इज डिसेबल्ड. When the clock is 0, this gate is disabled, this gate is also disabled. Now when the clock is 1, only then whatever the input is, that will come here. If it is 0, 0 and 1, clock ka 1, that is 0. If it is 1, 1, 1 become 1. So if it is 1, 1 will come here. If it is 0, 0 will come here. But this should be enabled, that is this should be 1. Clock should be 1. Same story with this. ठीक है ना. तो एक तो हम ये चीज़ करेंगे. तो पहला काम जो हम करेंगे, हम क्लॉक ऐड करेंगे, ठीक है ना. आई हैव पुट अप अ रॉन्ग लाइन्स हियर. ओके, नो प्रॉब्लम. सो एनीवेज, पहला काम जो हम करेंगे, हम क्लॉक को ऐड करेंगे. व्हाट विल सेकंड थिंग? सेकंड थिंग विल बी, we will add, we would like to remove the state, the 0 0 state. Okay, we want to remove the 0 0 state at all. So we'll do both things. So that we will do in the next lecture. Till then, stay tuned, stay smiling, and masalama.